What if you needed to find an element in a vector in Rust? Out of a big vector, you wanted to find one of the elements. Well, the first element, but just the one. If you needed to find just the first element, I don't know why you'd want to find just the first element. Usually you want to find multiple elements that match a criteria. In Rust, they have an iterator find function, and this function iterates over an iterator. It searches for the first value that satisfies a condition that you pass into it based on a closure. So it will execute that closure. Here's an example where x is equal to 2. And if x is equal to 2, it will return that, it'll return it. But you already know it's equal to 2. So we look here, we say find 2 in a vector, and it found 2, so it returns 2. If it tries to find 2 in vec2, which vec2 does not have 2 in it, even though it is the second vec, it is array 2, it doesn't have the number 2 in it, so it's going to return none. So you can use this find function in Rust to find an element, just the one, just for the first one, and it will return a reference to that element, which you could probably do something like mutate it or modify it if you wanted, if you set it up to do so. You can also use it for validation and things like that. Okay, so say you wanted to mutate a list, and you wanted to eliminate or modify only certain elements that match your search criteria, you could essentially use the find function, find the element that you're looking for, number 2, modify it to increment or decrement the number or change it altogether, and then reuse the find function to see if there's anything left that matches your search criteria. And that way you can sort of modify a list. I guess that could be one of the use cases in this case. Yeah, I'd probably more go towards the map function, because then you wouldn't have to put all these scaffoldings around using it, the find function, right? So if you need to find a bunch of items in the list, although this is potentially more CPU efficient because, well, I don't know. Okay, yeah, so it'll be a little bit more work. You could put this in a while loop and then sort of mutate out all of the number 2s, right? If this is something that you're looking to do with a vector or an array. Well, what do you know? I was playing around with this, and look at this neat little thing you can do with the find iterator. I didn't know, well, I guess in this case it's an iterator, so it has sort of like a next capability. You can use it to, let's change it up. Okay, let's find all values greater than or equal to 2. So we should see a 3 show up in here, and we do. This is actually neat. Okay, so you can use the find function in the Rust standard iterator find. Here we go, check it out. While let sum, iterate find, and then anything that's greater than or equal to 2, you can print it out. That's pretty neat. Okay, so the find function is a little more powerful than I was originally thinking. And you can use it in this pattern, and it's really simple and actually pretty clean to iterate over a list based on a search criteria. It's sort of like a filter to find exactly what you're looking for and only provide data here, and then once it's been exhausted, it will just continue onward from there. In addition to the iterator find function that you have in Rust also gives us the ability to see what the position is of that element within a vector or an array, like the index position. Is it, in the first spot, second spot, third spot? Well, there's a nice function called iterator position, and Rust will let us take advantage of that technique, which allows us to capture the position of the element. Oh, that's neat. Okay, so every odd number is what we're looking for here. Or no, every even number, sorry. Every even number. I like this. And also every negative number. That's pretty satisfying. Okay, so we can go back up to one of our examples up here, and instead of saying find, we can get position and then print out the position of where the element is. Okay, so this is odd. This is not what I was expecting. I don't even know if this is going to be super useful. In this case, guess what? It does find all the elements that we are interested in. It finds the 4 elements because we've got anything that's greater than equal to 2. It finds the position of those, but it only finds the first one, and it starts returning 0 for all the other elements, which is super confusing. Why would it do? It knows. Well, does it though? Does 0 count? What if we put a whole bunch of 1s in here? No, it knows. What if we put another 2 in? What is going on here? All right, I believe I have a good guess what's going on here. The internal positioning or the pointer within the iterator is keeping the slice of the vector, and it continues to progress the slice forward. In this case, it's going to return the position of the slice, but not the relative position to the original vector. So as you can see, we have 1, so that does not match greater than equal to 2, but then we have 2, which does, and so in our slice position, it's going to return 1 for our first element. And then the next several items here, 1, 2, 3, are matching our criteria, but those are going to be in the first position of the slice. Now we have to keep our picture. What are we going to use this for? Why would we, what's the so that's why these are zeros. That's why we see zeros here, because they will, and then we see a 4 all of a sudden because it doesn't match 1, 2, 3, 4 times. So right, so 0, 1, 2, 3, because it's indexing by 0, and then it returns 4. So it's the fourth position of the slice that's kept in the internal memory for the position of the iterator, which is not that useful. Under this scenario, I guess, where I'm trying to do a while loop where I consume the entire iterator, it is not all that useful. However, it's going to be useful if you just want to find the first element in the list, because then you can use that position information probably to go back and mutate the original list if you wanted. Although it would still just be the first one. So I guess you could keep no, you couldn't. No, there's no extra. What I'm trying to do here isn't really all that valuable when referencing the position function on the iterator. However, the find, I would say, the find function in the iterator is far more valuable, because you'll be able to actually, you know what you're looking for, and you can also find the value. And it works the way you'd want it to, because it continues to iterate through the list and it'll find all the elements that match. So just beware, if you wanted to use the position iterator search function, it will only be so, I mean, could you imagine some other use cases for the position? I don't know, because it doesn't work the way I want it to, where I could use the position information and go back and mutate the original list. In that case, we might as well just be using a map or filter on the list altogether instead of using the position thing.